In this video, we're going to be talking about inequality word problems. So we've touched on this a while back when we were talking about word problems in general. So most of this should be reviewed, but we're just going to talk about it again. We're going to talk about some of these common phrases, not some, we're going to talk about all of them. And we've touched on these before. I'm just going to go back over them. So if we see these words, we need to be thinking these symbols. At least is going to be greater than or equal to. It could be, if I say at least 5, I have to have at 5, but I could have more than that. At most is going to be less than or equal to. If I say at most 5, I can have up to 5, but I can't have more than 5. Same with no more than is also less than or equal to. I can have up to whatever that number is. More than, when we are reading it for inequalities, is not addition, it's just greater than. No less than would be greater than or equal to. So no less than is the opposite. We're thinking the opposite of. I have no less than, or I can have no less than 3 a day. I can have 3, but I can't have less than that. And then less than, of course, is strictly just less than. It is not subtraction in this case. Nowhere in this should there be equal signs. These are only inequalities, not equals. Right? And then we're going to go through a couple of these. But before we do that, we need to think back to our word problems. How do we solve word problems in general? We read it, we highlight or underline or circle anything that we find important. After we do that, we're going to define our variable. We need to know what don't we know and pick a variable that defines that. Then we're going to write in inequality and then solve it. So for this first one, I'm going to read it first and then we'll go through these steps. Keith has $500 in a savings account at the beginning of the summer. He wants to have at least $200 at the end of the summer. He withdraws $25 per week for food, clothing, and movie tickets. How many weeks can Keith withdraw money from his account? So things that are important. We have $500 in a savings account at the beginning. He wants to have at least $200 at the end. He withdraws $25 per week for those items. And we're trying to figure out how many weeks can he withdraw money from his account. So a couple things we need. First, we need to define our variable. Because we're looking for how many weeks, I'm going to use W. This is going to be what we don't know, the number of weeks. And then we need to put this number together, put all of these numbers together. We know he starts off with $500. He's withdrawing money every week. So if he's withdrawing money, that $500 is lowering every week. So that's going to be a subtraction. We know he's subtracting $25 each week. We don't know how many weeks, so that's where our multiplication comes in. We know he wants to have at least, so going back, at least is greater than or equal to. So when we're writing this, however much he's spending or withdrawing, the amount that's going down has to be greater than or equal to 200. That's how we know which way to write this. So we defined our variable, we wrote our inequality. Now, the only thing left to do is solve it. Right? So when we are solving this, our rules still apply for when we were solving inequalities. If we multiply or divide by a negative, our sign changes direction. Also, if you end up with a negative for a word problem, it's probably not right unless it's dealing with just numbers. Like Keith picked a number, da-da-da-da. If it's talking about just numbers, not real life, like money, amounts of food, amounts of clothing, anything that can't really be negative, you shouldn't have a negative. So I'm just going to redraw this because it looked a little weird. So he can withdraw money from his account for at least 12 weeks. To still have $200 at the end of the summer. I'm just going to say 12 weeks, not at least 12 weeks. Because we don't want him going over 12 weeks, because then he wouldn't have at least $200. So let me rewrite that. 12 weeks for at least $200. There we go. Now that makes more sense. All right, we're going to do one more of these, and we're going to do number 2. Oops. All right, a taxi charges a flat rate of $1.75 plus an additional 0.65 or 65 cents per mile. If Erica has at most $10 to spend on a cab ride, how far could she travel? So important things, flat rate of $1.75. So if we're thinking back to when we were doing word problems, flat rate means if you don't do anything else, they're still going to charge you that amount. So in this case, if she doesn't go any miles at all, like she asks to go around the corner or a block away, not even a mile, she would still get charged that $1.75. She's also getting charged 65 cents per mile. She has, at most, $10 to spend. And we're trying to figure out how far could she travel. So, variable, I'm going to say M for mile. We don't know how far or how many miles she could drive. So this is going to be the number of miles. That's what we don't know. And then putting this together. Well, when she gets in the car or gets in the cab, she's going to be charged the $1.75, and it actually says plus in here. But for every mile, she's also going to get charged that 0.65. So this is going to be an addition. Per mile is where our variable is going to go. And at most, so if we're looking back to our words, our key words, at most is less than or equal to. That means she cannot spend more than she has. So this has to be, less than or equal to. And then we're solving. So this means the most amount of miles she could drive, or she could ride, is 12.7. If she went 12.8 miles, it would put her over her $10. Right? And now you'll have time to practice some of these on your own.